Hello. Okay, let's start with blockchain architecture now. Okay, I will take the slide at the end of the blockchain architecture module so that at that moment, you'll have an idea about all the layers, if not entirely, but yeah, to a greater extent. Starting with the application layer. Now, let's imagine you're building a house. The first thing people interact with is in the foundation, is in the wiring, is in the, isn't anything about what is inside. It's all going to be about the doors, the main door, the paint, right? That's exactly what the application layer is in blockchain architecture. It's what you and I, as users and developers, even interact with directly. This is the layer where we define what a blockchain is supposed to do, requirements, what the system needs to do functional, and how well it needs to do non-functional. I give you the functional requirements, like I want to store the transaction securely. And then I give you the non-functional requirements that, hey, I want to handle 1,000 transactions per second with 99% uptime. That is what is functional requirements, and that is what are non-functional requirements. Then coming to service line agreements, SLAs, the people who are here and already there in some organization know how important this term is, how important, how important SLA breach comes to be in. So nothing for you, it's just a commitment on performance, availability, and security. User interface and experience. When user is interacting with the layer, that layer has to be, a very good UI UX built. That is, how seamlessly is my integration going to be with the system. And once we have all these set down, the application layer is going to percolate these down into the underlying layers, which means the entire blockchain network operates according to the rules that we set in the application layer, the the SLAs, the functional, the non-functional requirements. Going to the next layer, this is not actually the layer, it's about the blockchain tools, the blockchain libraries. There's a great news out for there for the developers. You don't have to start anything from scratch. There are blockchain tools, blockchain libraries. Think of them as ready-made Lego pieces. Instead of writing 1,000 lines of code, you can plug in frameworks, APIs, and just get started quickly. For cryptocurrency, we have Bitcoin's framework. For cryptocurrency and smart contracts, together we have Ethereum and Ripple. For enterprise blockchain, we have Hyperledger. So, you know what? In a way, these tools do all the heavy lifting for writing, deploying smart contracts, configuring network rules, maybe testing, monitoring, and maintaining distributed applications. Let's assume if you're building a supply chain tracker, supply chain, you remember? The one that you can actually use for tracking the coffee beans from the farm to your cup. So if you're doing a supply chain tracker, the application layer is going to define who can add shipment data, what counts as a valid update, how the tracking interface is going to look like to the person who's actually viewing it. And then you could use something like Hyperledger Fabric to implement it in weeks instead of, doing it in months, maybe years. So in very short, the application layer is where business logic meets blockchain technology, and it's where innovation happens. Let's come to the layer next. It's the security layer. Now that we've seen the application layer, the front door, let's look at the security system. The security system that guards it down. Not all blockchains are completely open, like Bitcoin. Many are actually permission, which means you need authorization to join the network. And this is in most cases the private or the hybrid blockchains, when sensitive data is involved. So the security layer has two big responsibilities, right? One is identity management and the second is access control. What is identity management? Every participant, the participant is called node here, okay? Every participant, you, me, anybody, has a digital identity, not just a username and password. It's a cryptographic identity that proves who we are. It is like I'm storing my role in the network, that maybe I may be an admin, I may be a regular user, I may be an auditor. So that is what is my identity, and that is stored inside the network. Then comes the next thing that is important after identity management is access control. Once you know who you are, once actually I know who you are, I can decide what you can do. Some nodes may only be having read access, some may be having only write access, some may be having validated transaction access. And the admin nodes, maybe they have the right to configure the network. And this is called role-based access control. And these are the two important responsibilities that my security layer has: identity management and the access control that is role-based. Now you may be thinking, why and how is this important, Cherish? So you imagine you are having a hospital blockchain, okay? You wouldn't want a receptionist to alter the medical data. You just want her to make an entry into the database that, okay, this so and so person has been admitted, so and so person has been discharged, but you don't want her, or don't want him or her to actually go in and make some alterations in the data. No. So yeah, in short, the security layer ensures trust inside the network. In permissionless blockchains, we rely on the consensus algorithms to maintain trust among strangers. But in permission blockchains, the security layer ensures everyone follows the rule because we know exactly who they are and what they are allowed to do given their role, right? Then coming next, the distributed ledger. We now have secured a blockchain with identity access management controls based on the role. Now we need to talk about where the data actually lives. And if the data is living somewhere, how is everyone agreeing around it? So yeah, welcome to the distributed ledger layer. This is actually the heart of your blockchain. Let's break it down to three parts: distributed ledger, consensus mechanisms, and your incentive or distribution mechanisms. Distributed ledger is your storage where the data is actually there. Consensus mechanism is the agreement, and incentive or distribution mechanism is your innovation to participate. Why would I be interested, in validating the blockchain, in validating the blocks of the blockchain? Let's start with distributed ledger in that case. Imagine, there's a master notebook that contains all transactions. But instead of being locked in one office, everyone in the office has a copy. And it offers the network. So, everyone in the network has a copy of that ledger. And this ledger, please keep in mind, this is append only. You can add new blocks, but never erase the older ones. This is entirely replicated. Every node has the same version, completely synced. One copy updates, others get updated too. So, 3 points that you have to remember about this ledger are: the ledger is append only. You cannot actually add new blocks. You can add new blocks, but you can never erase the older ones. This is replicated. Everyone has the same version. Synced. Everyone's copy is updated. If I make any change, your copy will also get that change. And then let's come to the second, consensus mechanisms. Now the thing is, I told you, right? If I make a change, your copy will also have the change. But if everyone has a copy, how do we make sure that all stay the same? This is where the consensus algorithm works in. Methods like proof of work, proof of stake, delegated proof of stake, or Byzantine fault tolerance. You don't have to remember all these big words. Just note that there are rules the network follows to agree on which block is valid and what should be added next, right? Because once you've added that block, you cannot delete, you cannot make any changes to that block secretly, right? So if one block is added, that cannot be deleted. Another block will be added just beyond that, right? So we need to have the rules that the network will follow to agree on which block is valid and which should be added next. Then, yeah, coming to the last one, incentive or distribution mechanism. In cryptocurrency, people aren't just validating transactions out of kindness. No, they are rewarded. In Bitcoins, miners get new Bitcoins, block reward, plus the transaction fees. In other blockchains, validators might get tokens, other benefits, something or something or anything they are getting to validate a transaction. And this mechanism, it keeps the network alive because if there is no motivation for somebody to do a work, they won't do that work, man. So the beauty of layer is that there's no single central ledger or central authority that everyone has to trust. Everyone has the ledger. Everyone has the shared copy, the digital ledger. And the network itself is now going to maintain the truth through the rules of consensus. And everyone can verify it. I hope this is good with you. With this, let's meet in the next video.